So the next topic is calorimetry. So calorimetry is just a technique used to measure the amount of heat transferred. And then they use calorimeters or as the instrument used, which we'll do in lab if we haven't already. And so the idea is pretty simple. You just take your solution or your reaction or whatever you're studying. You go ahead and put it in your calorimeter. In this case, on the left, we have this kind of coffee cup, pretty simple, basic calorimeter. You put that into there. You measure the temperature before and after, and then you can do some calculations and figure out how much the heat the reaction has released. And then here's just more examples of more fancy calorimeter, and then like an even more fancier calorimeter. The better instrumentation you have, the more precise numbers you can get. But the overall theme is the same. You add your compound / your reaction, whatever you're looking at, to the calorimeter. You record the mass and then the change in temperature of the calorimeter. It generally has water in it. And then you do some calculations. The main thing with these calorimeters is that they need to be well insulated so that all the heat that's produced / absorbed is transferred into the calorimeter. And not lost to the surroundings. So that's why, with these coffee cup calorimeters, they use these styrofoam cups because styrofoam is a pretty good heat insulator. And it doesn't even really have to be a calorimeter. It can be really anything, right? You can take kind of, a hot piece of metal, drop it into some water. You measure the mass and the temperature of the water beforehand. Let's say it's, at 25 degrees Celsius. And then after you drop your metal block in there, it's going to cool down. And your solution will be above 25 degrees Celsius, right? And then you can record all of these and do some calculations, with the main idea being that all of the heat lost by the metal will be absorbed by the water, right? So we have our Q's are going to be equal and opposite. One, we just add that negative sign because one of them is losing heat, the other one is absorbing heat. And then we can just expand our Q into our MC delta T, right? So negative mass of the metal times the specific heat of the metal times the change in temperature of the metal will be equal to the mass of the water, or your calorimeter, times the specific heat of your water times the change in the temperature of the water.